What's up, guys? So this is kind of our structure in the day. We are going to do Leetcode first thing in the morning, and then a few related exam revision stuff for a particular subject, cryptography and security. And then we'll go to lunch, gym, shower, then do some scheduler development once I'm burnt out from all of the other CS related, cryptography and security related exam revision. And then perhaps I might do a lecture as well later tonight. Alright. But first, we shall do a monkeytype once again, because this morning has been colder, my fingers are colder. And we'll do, oh no. And then we'll do a Leetcode problem. And we'll try to do the Leetcode problem quicker again. Yesterday it also went over an hour, which is not is not ideal. It isn't. So I don't want to do that long, but we'll see how it goes this time around. Percent. Whoops, that's the backspace. Percent-t, space, percent-t, space, percent-t, space, percent-t. 1, 2, 3. Return 0. Alright. Leetcode. Now it's gonna open it in a new tab. Move that to the side. It's nice that this tree is getting filled quite nicely now. It's good to see. Alright, but we have to do some backtracking problems. In the blind 75, is there anything that I'm missing? So I could be doing try, I could. But for now, I think we will do just a backtracking problem. We'll do permutations. Now I would expect open permutations. Let's open up Alacrity, and there's permutations, and we can link this Leetcode problem. So going to be a problem of backtracking, so include backtracking, and it's 46 permutations. So we will, so I think I can kind of understand why this will be backtracking. However, still Alacrity and Vim. (46 permutations.py). Okay. Now, given an array of nums of distinct integers, return all possible permutations. You can return the answer in any order. So you can have or you cannot have. I think that's the main idea. So the choice is if you can include or not include. So if that's the objective, then I think I know a way to go about this. Except I might also have to consider what the backtracking looks like again. So I might just go click on backtracking. So we should have it in boilerplate code, right? So where's boilerplate here? It's not. Sneeze, my bad. So I'll just open it up here on the side. So boilerplate. Now backtracking, I can, here, this is where we need it. So hash backtracking. Now in this backtracking problem, you can I can revise this idea. So this is the basic idea, but why subset? What does subset mean in this case? If it includes nums I, or if it excludes nums I, maybe. And then combination sum is also interesting. Now, if I remember this correctly, there's a problem of subsets, and this is the problem of combination target sum. Like, the thing that is the same amongst these two is this. This and this, like where you do two DFSs. And that's it. That's like you do you have two choices. But yeah, it's a bit of a problem. Okay, let me come back to this for a second. I'll come back to this idea, but now I'm going to shift my brain a little bit to quickly something that I learned last night so I can remember this well. So yesterday in the night I learned about well, I revised on cryptography and security. We had the Elgamal, which is different from Diffie-Hellman. The Elgamal takes well, you can encrypt a message with Elgamal if you have generator A and prime Q, which when you take the power or some secret power of A, so this is maybe K of A, K of Alice. K of Alice, you can use this AK now to times with M to get some ciphertext, and then Bob will decrypt with his own K times onto the existing ciphertext. And once he does that, he can divide by that value on the ciphertext to get the answer, M. Now, the thing is, you encrypt with what? You encrypt with Alice's, or do you encrypt with Bob's? You must encrypt with your own, right? And then you send to Alice. Alice will decrypt it on their own. But it's like there is no, like in which part is there shared secrets? It has to be that the public key is known. Now the public key is only known if It's the thing that's coming with the ciphertext. So what is it that comes with the ciphertext? What comes with the ciphertext is what comes with the ciphertext. It's the public key of, say, Bob. When Bob generates a key, so a to the power of kb mod q, a to the power of kb is what you give, not the key specifically, but a to the power of kb is what you give. Yeah. Hello, Shah Jalani. Hello, man. What's good? I mean, I'm trying to just revise a few things right now, and then get back to this Leetcode problem. So I'm just trying to recall exactly the Gaml crypto system, and I remember most of it now. And what I don't remember is the modes of encryption. Now that is modes of operation. So now that's the next thing I'm trying to remember. So we have the electronic code book, ECB, which, given an input plain text, you pass it to an encryption function with a key to get an output ciphertext. Now, the problem with this is you can notice patterns in using ECB. If you use then the next best option, CBC. CBC is a block chaining approach. Is a block-oriented approach. So that means that you need each block, I guess, to perform the next block computation, but during the encryption, I think. So if you have... is that true? Let me think about this for a second. I'll come back to that. I'll bookkeep it. So then we have CBC, so that will take in... when encrypted, we have... actually, that's the thing. I need to talk about encryption and decryption. So going back to ECB, we have, when we decrypt the ECB, it's going to be the ciphertext passes to the decryption function with a key, passes to the plaintext value. Now that's simple, as is. The CBC, okay. Now the CBC, I can draw it out, I guess. Let me try and explain in my head before drawing anything out. So I think having it in my head is better than drawing it out right now. So the CBC, we will have originally the plaintext, which gets XORed with an initialization vector, and then passed through an encryption function with a key on the encryption function, and then output a ciphertext. The ciphertext then is used into the next stage of, or the next block of the message, where you have a plaintext again, XORed with the previous ciphertext to get the input to the encryption function with a key, to get the output as that next block of ciphertext. Now this continues indefinitely, and then you would have, say, the decryption algorithm. You would have the ciphertext, decryption function with a key to get some plaintext that was XORed previously. Now this is where you use the initialization vector, XOR that, to get the plaintext and you'd move the plain text. Ooh, what would you do? You would need to use the ciphertext from the previous. Right. So it's fine with what I have, but the next ciphertext gets passed through the decryption function to get some initialization vector XORed with the plain text. Now the ciphertext is actually not the initialization, it's the ciphertext that gets XORed with the plain text. And that is where we get that decryption of the CBC. Okay. And if I have a look at what that looks like more closely, it's actually going to be here. Whoops. But I need to find it. So decryption is using the ciphertext directly. Yeah, I agree. That makes sense, very much so. Matthew, hello. Watching from your bed. Nice. Shah Jelani, so Shah Jelani, are you looking for a job right now? I am just studying, but I do have an internship already lined up. The next step would be to find a job, so I'm still doing the Leetcode problem. Same, but I have to solve a problem too. What course is he taking? I'm taking cryptography and security at the moment. This is a cryptography and security subject. Anthony, so hey man, I hope you're doing great. How do you have your Obsidian set up? I feel like mine is all over the place. You should make a video or guide. Yeah, for sure. I mean, I can make a video or guide, I think. I'll probably will talk about it. I'm wondering if now is a good time or not. I might talk about it later tonight. You know, I'll keep this question booked. Right, so I'll keep this question bookmarked and then I'll explain it. Then it can be turned into a video. But on the basic concept, it's like I mainly use Excalibur here on Obsidian, so that's kind of the reason. Obsidian, when I'm using it here, Excalibur I'm using here, so I can actually write on this with a pen, because I got an iPad as well. But the iPad here, it's still bad. It was still not as clean to use an iPad here and Excalibur on Obsidian, just on this, and you'd have to set up like a self-hosted live sync. So I wouldn't even recommend my method of doing things, because Excalibur, because my self-hosted live sync method is kind of pedantic, and I don't know if I'd want other people to experience my kind of pain. It's a little bit yeah, I don't think it's worth the struggle, is what I'm saying. Because if you have like 3 gigabytes of, I don't know, notes, and then you try to sync it all up together, it gets a little bit annoying. So I wouldn't wish it upon my closest friends to do it this way. You'll get an row, don't worry about that. Hello, Dusty. So, are you a CS major? Yes, I am a CS major. I already graduated. I'm doing a master's of specializing in AI at the moment. But I'm learning cryptography and security as kind of like a side subject, which I think will be useful regardless. Now Dusty asks, how do I normally study? I mean, watch the lectures, write notes on the lectures, usually. in terms of like right now, I have to like review stuff a lot for exams. Now I try to explain it to myself like what I was doing before. So, yeah. So you're basically into Web3 right now? Not really. Not really into Web3, because that's more like blockchain stuff. Although I am talking about cipher blockchaining, I think that's different to blockchain. But there's probably a similar underlying concept to it, right? But I'm not particularly interested in Web3 at the moment. But who knows? Maybe in the future, if it goes big, I know it's already been pretty hype, but yeah, I'm sticking to my guns at the moment, and I won't look into Web3 that much. I'll stick on. I'll stay onto what the web was before. What is it? I don't know. What was before Web3? I forgot the name. Was it really just Web 2? All right. So look, so that's, I talked about cipher blockchaining, right? Now we will talk about we have the next one being the output feedback and the cipher feedback. So the cipher feedback directly from a plain text, you pass that through a encryption function with a key. Now, is it a plain text at the very top? It's maybe an initialization vector, right? It's an initialization vector, we'll say, that goes through an encryption function, takes a key, and as output, it would return, it was just some random, pseudo-random string. Now, this pseudo-random string gets XORed with the plain text to get a ciphertext. And that is the first step. So we have the output of the actual encryption function in the output feedback goes into the next encryption function. Man, I'm saying a lot. But it goes to the next encryption function. Same key. Initialization vector is replaced with the output of the previous encryption function. Output is a new pseudo-random value that gets XORed with the plain text to get a ciphertext. Now that is output feedback. The decryption of output feedback would be you give the ciphertext, you XOR with you don't know the plain text, but you do the ciphertext. I think you still have the initialization vector at the top actually, so then you do a decryption with the same key to get some pseudo-random value, which is the same pseudo-random value that you used to encrypt or to XOR with the plain text. So then you just do the ciphertext plus the pseudo-random value, XOR with the pseudo-random value to get the plain text. And then from the output, so this is in output feedback. When you have the output, pass it through, as the input to the decryption function with some key, you should get another pseudorandom. So the pseudorandom is sequential, and that's what makes it, I guess, streamed, I guess. So let me just see then. If I scroll over a little bit, I should be able to see it. Okay, so that's I should have scrolled downwards. But, okay, actually that's not it either. Let me zoom out. Okay, it was this one, okay. Plaintext, ciphertext, nonce, output. Yeah, so that was the way that I was describing it. How many hours does that course take? I don't know exactly, but we're talking 12 weeks, because each of the subjects are 12 weeks long. This is actually one of the subjects that are a lot more intense than the other ones. That's why I'm learning it a lot at the moment and trying to learn it well. So, but also right now I'm only on the review stage at the moment, so I'm just trying to remember what I said to myself last night about these topics. Hello, discipline. Hello. Okay, so now in terms of the cipher feedback, it works in a similar way, but instead of using the output of the encryption, use the output of the ciphertext. Now, there was something about shifting bits. You shift bits in the case where the ciphertext is not the same length. Like, I don't see how the plaintext can't be just the same length as the ciphertext. Sorry, as the output pseudo-random value. But we're just going to assume that that's what we have, right? So S bits of P1. S bit cipher feedback. And an output feedback. I guess what makes it streamed and what makes it not streamed or blocked is because in a stream cipher, you can do S bits where S is equal to 1. It's a variable. Is that a way to think about it? What is the proper difference between a streamed and a block cipher, right? That is the problem that I got to figure out. But all right, last one is the CTR, which is the counter method or the counter mode. The counter mode should be pretty simple. You just have some nonce to begin with. You encrypt with a key to get an output. The output gets XORed with the plaintext to get the ciphertext. And now the nonce is the difference maker. So then you increment the nonce value to get different pseudo-random values as your output, which you can then XOR multiple times to get, you can XOR to get the ciphertext from a given plaintext. Now that is this counter. Yeah, so it's like a nonce, it's like a counter, yeah. And when you decrypt, you start from the first counter again, and then from the ciphertext, you just XOR with that value to get the plaintext. Now, that is interesting that you do just encrypt the whole time, right? Encrypt, encrypt, encrypt. Maybe that is the difference. Decrypt, encrypt. No, I don't think that is actually. That's not the difference, because counter mode is a block mode. So block-oriented transmission versus stream-oriented transmission. Like, what's the difference here between these two terms? Well, block-oriented. So block-oriented storage devices. Mode for block-oriented storage devices. Okay, that's not exactly the word that I was looking for. So stream oriented, block oriented, stream oriented. What makes stream oriented like what is stream? Random bit generation and stream ciphers, stream ciphers, stream ciphers, stream ciphers, stream. Vernam cipher. I gotta remember some of these are more foundational or simpler encryption and decryption algorithms at some point. But okay, a stream cipher is one that encrypts a digital data stream 1 bit or 1 byte at a time. Examples of classical stream ciphers are the auto-keyed Vigenère cipher. A block cipher is one in which a block of plaintext is treated as a whole and used to produce a ciphertext block of equal length, typically a block size of 64 or 128 bits. As with a stream cipher, the two users share a symmetric encryption key, used for some of the modes of operation explained in Chapter 7. A block cipher can be used to achieve the same effect as a stream cipher. Far more effort has gone into analyzing block ciphers. In general, they seem applicable to a broader range of applications than stream ciphers. The vast majority of network-based symmetric cryptographic applications make use of block ciphers. Accordingly, the concern in this chapter and in our discussions on symmetric encryption will primarily focus on block ciphers. Okay, well, stream ciphers are based on little bits, or one bit. A bit at a time. Do you have tests for master program? Yeah. I mean, we had like a mid-semester test. We had there were quizzes that I had for other subjects. Those weren't exactly some of them contributed, but I guess every subject had like a mid-semester test this semester. For me. Okay. All right. Cool. I think I reviewed all that now and I understand the differences. Now back to this question. Alright, so this is on permutations. Alright, permutations. Undo. Okay, given an array nums of unique integers, return all possible permutations. You may return the answer in any order. Now, 1, 2, and 3, cool. 1, 3, and 2, cool. 2, 1, and 3, cool. 2, 3, and 1, cool. 3, 1, and 2, cool. And 3, 2, and 1, cool. So, in this, the problem is the ordering. So it's not necessarily just removing the value, it's the ordering of the values. You know, when the length reaches 3, that's when you know to go back, maybe backtrack. Actually, how would you go about this? So you look at the first value in the nums array. The first value is 1. You put that down. And you say there are 2 choices that you can choose between, 2 or 3. And you would say, okay, 2 comes first or 3 comes first. And then from the remaining in the backtrack, what do you have? You have 3 and 2. When the list becomes empty, you know that is an option that you will add to the resulting list. And you would keep on backtracking up, and then you realize, okay, at the very first position, you can say, and you can choose 1, or you can choose 2, or you can choose 3 to begin with, and then the rest is history. Okay, I can kind of see how this could be a backtracking problem. We're going to return the result. We're going to say this is a definition of a DFS problem. This is going to be return some value. We're going to DFS again internally twice. Well, actually, it's going to be DFS'd within a for loop, so that's something to consider. The input will say we take a nums. Alright, so the nums here is what's really going to make a difference. The nums DFS now depends. So for n in nums, I guess, or let's just say for I in nums. Now this is going to be the len of nums. Going to be the range len of nums. I nums I is it going to be +1? If you start from 0, right? If you start from 0, you want to say go to the 1 DFS. And you want to say actually, this isn't the right way that I was. I don't think this is the right iterations that I have to do here. You're going through each of the nums. That's the thing. You're going through each of the nums. And you're adding these nums with something else. So this is going to be, I guess, I could say index, I guess. I can say index, I think. And maybe make this j. Maybe j. But nums of I. Nah. I gotta actually make this nums of j. And make this equivalent to an actual num. If I make that an actual num, then this num is added to some construction, so constructor. I'm going to say it's some constructor dot append num, and at some point you're going to have to constructor dot pop num, or pop. Alright, I'm just going to pop that value off the top because you're doing this in a DFS manner. So when you append that though, if the result, if nums is, so if len of result is equal to len of nums, then you, so okay, constructor, sorry. Constructor, if len of constructor is equal to len of nums, constructor res.append constructor res.append constructor copy. Okay. And DFS of nums j. Now we can probably just call it I again. Nums I with nums decrementing Now the problem is we're going to have some issues. Damn, that's we're gonna have some issues. Let me think. There are some problems just me looking at this. There are many problems when I just look at this. I don't know, you have a constructor, you append the number to it, and then you would add that number only if this is true. Now, each of the remaining numbers in nums we do a DFS of this and nums I. Now it's not nums I, is it? Because it'll have to be it just has to be that num with that removed. Can I make it so it's not removed like that? Num and nums. Now let me be straight with what nums is here and what num is. So num is the value that you want to add to the result. Nums is the remaining values that are left to be added. Now, does that mean that you really need num? Because here's the thing, right? You want to return, so you want to do a DFS of nums. And that's basically all you want to do. So I don't think it makes sense to put that there. But if it doesn't make sense to put that there, it means that these have to be moved. Possibly, perhaps, inside here. So that these are indented. So in the DFS, you're doing a for loop. For whatever's remaining in nums, you have a constructor where you add the num. Now the num here is just nums I. And then if len constructor is equal to len of nums, res append constructor copy now it's not len of nums anymore equal to n. Well, technically you can say if, instead of nums, if ci, wait, change this, whoa, okay, whoops, change, yo, why is that highlighted like that, actually, kind of sus, it's kind of bugged out there. Okay, if nums is equal to just an empty set, right, that's the base case. But if it isn't, you would append that, and you would do a DFS. Of the remaining nums. Sorry, you would do the DFS of the that remaining nums. You kind of want to do nums excluding whatever is in nums. Next level CPP. Look up for swaps. Every time you swap different elements to get a new combination. Every time you swap different elements to get new combination. Yeah, I can see that as a way. I'm thinking of it a different way. But we'll probably end up doing it your way eventually, probably if that's the right way. We're going to do everything else excluding this value. Okay, so I'm going to say it's going to be nums let me think. So nums, so I want to weigh, so this is if I is 0, or what if I is 1? So up to 0, plus equal or plus nums I plus 1 . Is that good? Assuming I plus 1, that's okay, so I don't know whether you can do this, so I'm gonna just check. So if you're given an array, right, that's equal to 0, 1, 2, 3, and you have what's array of, so let's say I is equal to 0, Now, array of I, that's going to equal to 0, 1, 2, 3. When you have array of I plus 1, 2, and you slice it like this, that should be an index error? No, so it'll be from I plus 1, so it's going to be 1, 2, 3. But now what if your I is equal to 3? I is equal to 3, you have 3, or you have nothing, I'm guessing. Good, okay, so nothing is good. This is what we need, so that should work. Partially. Okay. Yeah, we got it. Let's go. All right, that was good. That was good. That was good. We figured it out without even looking at the solutions. So I'm happy with that. But let's look at the reasons here. Okay, now it doesn't even look like we use a. Doesn't even look like we use the DFS at all. Am I right? Is that? That's interesting.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem. Permutations. I've actually already solved this
Thanks, next level
before,
CPP.
but I think I could explain it a bit better, so I wanted to do it again. We're given an array of distinct integers.
You do Leetcode in CPP? Yeah.
Possible permutations
I do it in Python.
So for the record, a permutation of a set of numbers like this would look something like this. We have 3 numbers, so we're going to have 3 positions to fill. For the first position, we have 3 choices. We can pick any of these 3 elements. So let's put a 3 over here. For the second position, we don't know which element we already picked. We could have picked this one or this one or this one for the first spot. But either way, we know we're going to have only 2 elements remaining.
Yeah, Leetcode is good.
To place over here. So there's going to be 2 different elements that go here. And then after we've picked the first 2 elements, this one is already decided. So we'll put a 1 here. So 3 times 2 times 1, we'll have 6 different permutations of this set of numbers. And in order to visualize it, let's kind of draw a decision tree. So let's say that for the first choice, we can choose among 3 elements. We can have 1, 2, or 3. So regardless of which path we take, we're going to have 2 choices. Here we can have either a 2 or a 3. We can't have a 1 because we already picked it. Here we can have a 1 or a 3 because we can't have 2. We already picked it. Here we can have a 1 or a 2, but not a 3. So now it's going to get a bit more simple. We'll only have 1 choice for each of these, and it must be the element we haven't chosen. So here it's going to be 3, here it's going to be 2, here it's going to be 3, here it's going to be 1, here we haven't chosen 2, and here we haven't chosen 1. So now, if you go through each path, we have a permutation. We have exactly 6 of them, and you can see every single one of these is different. So if we could have each of these in an array, this is the result. Like, we've calculated the entire result. Now, the only problem with the way we're thinking about it here is it's pretty easy on like pen and paper to draw this out, but how would we actually calculate this in terms of code? Obviously, it looks like we're using recursion, and it's definitely possible to do it that way, but the way we're doing it right now involves a decent amount of bookkeeping. Because what exactly is the subproblem? Like here, we chose 1, right? So we got rid of 1, and these are the elements remaining. So now we're trying to create permutations with those elements.
Wait.
But here, the subproblem is different.
Oh, he does
here
do DFS.
2, so now we have these elements remaining, and we're trying to create permutations with those elements. Again, we could do it this way, but it would involve like removing this element and doing some other stuff. So I think a slightly easier way to think about this problem is to really use the idea of subproblems, because it makes recursion very, very easy. So let me kind of redo this in a very simple way. Now we're still going to use recursion, but we're actually not even going to branch anywhere. So you're going to see something interesting. Here, we have 3 numbers to choose from. So what we're trying to do is give me all permutations from 1, 2, and 3. But Next,
Yo,
the subproblem we're
I just remembered I had a tool that I could use to draw as well. Because I'm looking at the way he's drawing things and I do have something similar, but where did I put that? It's called a Wacom tablet, but I'm trying to remember where I put that. Oh, wait, is it right here? No. Or did I sell it? Wait, did I sell it? Damn, I shouldn't have sold it. I sold it on the, like a market. Damn, wait, did I really sell it? Do I regret that? Man, it's alright. Yeah, I think I did sell it. I never thought about it until now. It's been like 4 years. It probably was never going to be used anyway.
Ask is this: give me all permutations with just these two numbers. So we're going to have something like this, 2, 3. And then finally, we're going to ask, just give me all permutations with just a single number. Notice how it's getting more simple as we go down. So watch what the return value is going to be.
Yeah,
well,
next level
go to the
CPP.
base
If I
case.
really
don't
needed
have
it, I'll
any
buy a new one.
elements, from here, I'm going to return up an array with an empty list. Like, that's our permutation. We can only create one permutation with an empty set of numbers, and it's an empty permutation. So that's the base case, just to keep it simple. And now it's going to stay pretty simple. With just 3, how many permutations
I'm going to
do we
stand.
have? Well, it would look like this. We're going to return up to the parent just a single array with the value 3, because a single number can only be permutated like that. Now it's going to get more interesting. From here now, from this subproblem 2 and 3, how do we solve it? Well, you probably know what the return value is going to look like. It's going to look pretty simple, just like this. So it's going to have 2 in the front, and it's going to have 2 in the back. So 3, 2, like this. So these are the 2 permutations we can create. Now, the reason I'm showing you this way is so easy to calculate. Just watch this. From the base case, all we do is just add 3 to that list. Okay. Now, from here, this was the numbers we're given. We already got all permutations from 3, so now the only thing to do is to add 2. So what we do now with this array, it's a very simple array. It just has one element. So we know we have 2 choices, actually. With 2, we can put it at the front, or we can put it at the back. So that's exactly what we do. We create a permutation with 2 at the front, and then we create a permutation with 2 at the back. And then from here, we're going to do the same thing. We have these 2 permutations, 2 and 3. What we're going to do is try to put 1 in every position. We're going to try to put 1 at the beginning. We're going to try to put 1 in the middle. And we're going to try to put 1 at the end. So we're going to end up with 3 different permutations. We're going to do the same thing with this one. We also have 3.
His brain is more flexible than mine.
It's obviously different from 2, 3. So we're going to put 1 at the beginning, in the middle, and at the end. And if we do this, we're going to end up with 3 more permutations, which is 6 total permutations.
Because I thought of it more formulaic.
And if you're curious, I'll quickly draw out
This
those
is more
permutations.
creative,
Here,
I would
one
say.
goes at the end. Here, 1 goes in the middle. When I said end, I meant beginning, sorry. Here, 1 goes at the end. And from this permutation, 3, 2, we're going to put 1 at the beginning, so 1, 3, 2. We're going to put 1 in the middle, 3, 1, 2, and we're going to put 1 at the end, 3, 2, 1. These are the 6 permutations. Now let's code it up, and I'll also explain the time complexity in the coding solution. So we're going to start with the base case, which is pretty simple in our case. We're going to have the length of the input, and when it's equal to 0, we're going to return a list with a single empty list inside of it. And so the reason we're using that is because we're only going to have a single parameter, the input list. The idea is that we're going to keep calling the recursive function with the input nums without the first element. So that's the subproblem. Just get rid of the first element from nums. Just create a subarray starting at index 1. and that'll give us all the values from nums except the first one.
Okay.
So these are our permutations, like our subproblem, and then we want to, from these, add the current element, which is the number at index 0, to all of these in every possible position. And we're going to store those in another variable, which I'm going to call result. That's what we're going to end up returning from this function. Now, to actually do what I said earlier, let's just go through every single permutation that we have. And for each permutation, let's go through every possible index that we could insert the current value into that permutation. So I'm going to get the length of p. I'm also going to have +1 because we technically could add to the end of the permutation as well. So now, for that permutation p, I'm actually going to create a copy of it because we're going to use this one multiple times. We're going to possibly add a value to it in multiple different places. We don't want to modify the original permutation. We just want to create a copy of it. So I'm going to store that in a variable called pcopy. Then for pcopy,
so let me understand this.
Index I,
you're telling me that pcopy here is from permute, which could return a list of lists. So this is a list here. This is a list copied.
Value nums at index 0. We're taking this value, inserting it at this index. We're going to do that for every index.
Yeah.
And then we're going to take pcopy and append it to the result.
Yeah.
We're going to do that for every permutation, and then the result is going to be here, and then we're just going to go ahead and return. Now, as you can see on the left, this solution works, and it is very efficient. Well, it's about as efficient as we can get for this problem. And let me just kind of show you how to analyze the time complexity. The idea here is it's going to be easier for us to do it without kind of focusing too much on the code. Remember that how many...
All right, let me think of my time complexity here. Because we're doing a DFS on the different branches, you know, it starts off with, you know, the branching factor slowly decrementing, but by 1 every level deep. So given nums, it's almost as if it's 2 factorial. I mean nums factorial. Is it not just nums factorial? Because it's a permutation anyway.
How many permutations are we going to have? Well, if we have 3 elements, we had something like 3 times 2 times 1. That is a math equation called n factorial. So if we have n elements in the input, we're going to have this many different permutations. How do we build each individual permutation? Well, to add a single element to a permutation, we're like inserting in the middle. That's how we're coding this up. So it's an n operation, and that's just inserting one element into a existing permutation.
N.
If we're inserting n elements into each permutation.
So unlike the most of backtracking questions, this question is O of n factorial, not O of 2 to the power of n. Because every number can go any index. It's not a binary choice anymore. Yeah, I agree. So yeah, that's a good... yeah, I did say n factorial, so perfect analysis. All right.
We're going to have like an n squared over here.
Let me wait. So
like
he says n times.
That's how we're coding this up. So it's
n
an
factorial.
n operation, and that's just inserting one element into a existing permutation. If we're inserting n elements into each permutation, we're going to have like an n squared over here. So the overall time complexity is going to be n factorial times n squared, but this is really the dominating factor in the time complexity, n factorial. Space complexity wise, if you're not counting the output, which is just going to be n times n factorial, because each permutation is going to be of length n, and we're going to have this many of them. If you're not counting the output, and you're just counting like extra space here, the space is still actually going to be n factorial times n, because we have multiple copies of it here. So
okay.
This is time.
So I mean, next level CPP, that's a... I'm literally just going to write what you said. So I will literally just copy what you wrote, and just reference you, to be honest, because that's a good way to express things. So thank you for your input. Perfect.
Don't even branch in this recursion. Isn't it possible to solve this problem without recursion? And you're exactly right. The logic is going to actually be very, very similar. Like, we're going to start kind
So
of
he's
with
going to
this
try
as the
and
base
think
case.
of
I
it
think the time and
iterative.
space complexity is going to be the exact same, so I guess I'll leave this here. But this, we're going to call this our permutations, and we're going to get rid of this because we're not going to have any recursion. I want to leave this code here because I want to show you how similar the solution is going to be. Remember, this is the base case. We want to compute like the subproblem. So for every number, I could use like an index I to make it more clear, but we don't need to. I'm just going to go for n in nums. For every number, we want to now add this number to all the existing permutations. That's what we're trying to do. That's the logic behind this. So I'm going to call the new permutations we create with this number, the new perms. It's going to be just an empty list for now. We're going to go through every existing permutation, kind of like we did down here, right? Going through every permutation. And now I want to insert this element into every permutation, and I need to do that for every position. So I'm going to say for I in range length of p plus 1, exactly the same as we did down here. And now to that permutation, I want to create a copy of it just like we did before, and then I want to insert into that copy the current element. At index I, we want to add n, so this is slightly different, I guess. It's not nums of 0, it's n. And also, I want to say, let's take this now and add it to new perm. So new permutations, append p copy. The only difference here is going to be at the end, we want to update perms to be this now. So we're going to set permutations equal to the new permutations. And then at the end, we're going to return the permutations. So you can see that the code above is very similar to the code below.
I agree.
And I kind of got rid of the base case here, so this is not like the complete code, but you can see that this portion of the code.
I guess it's cool that I'm looking at this problem
this down here, and I'm going to run
not iterative anymore.
And show you here that it also works, and it's also just as efficient in terms of big O at least. If you found this helpful, check out Leetcode.
So the thing is, like, with these problems, like if I were to do this permutations problem when I first started, why is everyone getting beats 100% now? Is it really just faster? Like, what happened to Leetcode? I mean Leetcode. Not even telling me anything useful now. What was I saying before? Doesn't matter. It's broken, you think? Yeah. I'm sure you're experiencing the same thing. Okay, yes. Paste. Here we go. Oh yeah, so what I was saying was that when I'm doing these Leetcode problems, like say this permutations problem, if I first, were to get into Leetcode and I did permutations 46, I probably wouldn't be able to solve this in a DFS way or really understand how to do this in a backtracking approach. But, I would have done this problem iteratively just like what Leetcode would have done there. So it's really interesting that I'm able to now, like this is a sign of progress, that I'm able to now do this permutations problem, not instinctively thinking that it's going to be an iterative approach. So that's still good, even if the iterative approach is the same complexity. Solved without help. Watched video solution to understand iterative and recursive approaches through Leetcode. Okay, and this is Leetcode also explains the iterative approach which is something that I would have done if I hadn't known / learnt about backtracking in the first place. So it's good that I learnt about backtracking to be able to solve this problem the way I did. So I'm happy with that, and one of the key things from the solution I created was the use of a constructor, and which I take a copy of every time. And it's just about the way you think about the problem and then just solving it the way you want it to be solved. Palindrome partitioning is a good backtracking question to you too. You can try it. I'll get to it. The problem is we're going to call it a day for now. But okay, yeah, palindrome partitioning. It's going to be in an upcoming Leetcode problem anyway. So Leetcode problem anyway. So I'll do it then when I get to it. But yeah, perfect. That's good. So we'll call it a day for Leetcode for now. So this is done in relatively good timing because that's around 40 minutes. So maybe it's been an hour, maybe. But I think that's pretty good now. We can call this a day. Close it. We already committed it here, so we can exit. And we will now continue with some of my other studies. So I've got the live now kind of going. CS. So I have to go to bed. It's 2:40 AM here in Egypt. Okay, all good. Good luck, man, and good luck to you too, and sleep well, alright? Talk to you soon. Okay. So now that we are done with that, let's tick that off in our Leetcode. Now, I could do rest of exam paper questions right now, or I could try and revise on a topic first before I do that. And I think I will revise on a topic first before I do that. So, let's see. Say hello to the one person in chat. Cool. Just gotta fix the camera. Nope, it's not fixed. Still not fixed. It's just not fixing itself. Okay, now it's fixed. Brr. Okay, let's see. So I need to revise on a few concepts which I say at least 2 today to understand well. It's good that I've written these down, to be honest. See, where is the other page? Here. Okay. So our gamma encryption we've done. We've done modes of operations. Polynomial rings is a big one. But Elgamal's signature scheme is something that I could just do right off the bat. Schnorr's signature scheme. So if I go to this though. Okay, this is important. Now, where does this come from? Signature from discrete logarithms assumptions. So this is week 9. So this is, I'm guessing, Elgamal part 2. Yes, it is. Yes, it is. It is Elgamal part 2. Okay, this is where we can write some interesting shit. This is where we can write some interesting shit. Yeah, and also polynomial rings, right? Okay. So let's say the main topics of today is to revise these missing understandings. Polynomial rings I have to use, understand. Yeah, that's fine. Hello? Okay. I am deleting stuff unintentionally. Yeah. This one's on message authentication code. Do I still understand what message authentication codes are? Like, what are message authentication codes still? It's designed at providing authentication. With encryption, it can easily integrate to provide secrecy. Okay. So, yes, message authentication codes. Still a good question. MAC is a keyed hash function. I guess that's the takeaway. It provides authentication, as is the name, message authentication codes. It's a code because it's a keyed hash function. So it's a symmetric key primitive. You could say a primitive is an algorithm, I guess. Okay, primitives are the universal exchangeable building blocks. In cryptography, most commonly ciphers and hashes. Anything lower than that, Merkle-Damgard, Eastal, or SPM is usually considered a design choice or design strategy. A primitive is anything sufficiently generic, but the term should refer to the abstract syntax security definitions, not specific instructions. I wouldn't consider SHA-3 to be a primitive, but hash function is. Right. As others have pointed out in the comments, cryptographic primitives are generic building blocks. What exactly this means depends on your point of view and the level of abstraction. The most basic primitives are those where a function is considered secure, but either you can't break it down any further, or there's no security argument for its individual parts. Examples: modular exponentiation in prime fields can't be broken down anymore, and we can use this with the inherent discrete log problem to create public key cryptography. Modular exponentiation in prime fields. Yes. Symmetric encryption, we consider symmetric encryption like AES, which clearly defined security properties, but this is individual, but its individual parts, the single round of single steps in the rounds don't have any meaningful security properties. Sure, they bring certain amounts of confusion and diffusion. However, the strength of the cipher is also a result of the entire construction, as e.g. attacks on AES with reduced rounds are known. And then there are primitives, which are not specified any further. For example, if you assume a public key encryption scheme and just needed its generic algorithms, EncDec, then encryption scheme is your building block. It isn't the underlying trapdoor one-way function because you don't care which one is actually used. Yeah. Okay. I get it. Anyway, max. Fair enough. I can get a general broad idea of what max are. So let's see. Mac. Yeah, so max can be used as internal error control or external error control. HMAC is another thing. All good, Shah? I'll see you later. Alternate approach given the construction of JWT is to use digital signatures where the signing authority manages a private key but the gateways perform token verification using public keys. But the use of digital signature introduces the computational cost in comparison to HMAC. Yeah. Schnorr's signature scheme is something I'll revise. Okay, here we go. Now this is this page that we need to remind, to redo, to re-understand. All right, so we know now LGAML. All right, now we look at these and these should help me immensely to understanding the rest. So signature for discrete logs assumption. Now signatures from discrete logs assumption, main ideas, direct signature scheme, idea behind LGAML signature, Schnorr, DSA and BLS. So here's the thing, we also need DES at some point because I am totally forgetful of what DES means here. So we need DES. Now DSA and BLS is both interesting. Alright, be right back. Gotta quickly just check something. Now, why is the goal signatures from DLP? In RSA, signature and encryption functions are inverses. Are they? Oh, they are. I guess what makes RSA different from LGAML? I guess LGAML is an A value and you're just doing the message directly, I guess. Yeah, that is some distinction that I'm gonna make there as well. So RSA, we're gonna write RSA here as well. So before this there was also RSA. Valid signatures should always verify. Each user generates the key. Okay, so this is kind of LGAML. In G, yeah, sure. E minus 1. We got the properties from group theory. There's P1 integers less P which are relative prime to P. Consider P as a prime number. For all x P to the power is equal to 1 for Fermat's. Well, the phi function, is that Fermat's or is that Is that Fermat's? Is that Fermat's? It's not Fermat's, is it? That's Euler's theorem, I think. Similarly, this is equal for any integer t. In other words, m is equal to 1 mod p if m is equal to 0 mod p minus 1. What? Oh shit, that's another way to think about it. Damn. Okay, yeah, because it's a factor. Oh shit, man. This is how you meant to think about mods. This is like actually crazy, a crazy way to think about mods. No, it's like, you know, the proper way to think about mods, but it's just so smart. So taking it one step further, consider a prime. For any integer I, k we have some this, which is just I, why? Because I is equal to this, which then means it's equal to 1k, which is I this, and then this gives a strong result. If I is equal to j mod p minus 1, then I is equal to j. Yeah, okay. Yeah, that's all making sense to me. So central idea, verify linear equations. So Sana can provide values a, b, x, gx, gx1, gx2. P minus 1 because any person who knows x1 and x2 could have set this up. So you know g of y. You can find what g of y is. Alright, so if that's the idea, so it's verifying linear equations. That's the idea here. Examinable the variations of Galois, so that's going to be very, very important. Okay, this is going to be very, very important, everything I learn right here, alright? So you can't just stop at Galois encryption, you have to go to the signature scheme, alright? The essential idea. Okay, Galois signature scheme. So Alice has a public key YA GXA mod P. So G P public. XA is private, YA is public. And let M is equal to some hash of a message And we can set up a linear equation where m is the result. Alright, now m is the result. Oh wow. Alright, now where xa is secret, you choose a random k, and you add them together. Now you might need to relate this to what you had previously with our Gamma encryption. Now, you know, where would you read up on El Gamma encryption? That's very, very good question, but yeah, this is it. This is the page. Now, in which one would you say is the most important page? It would be this page, or this page. We'll say this page. And go back. All right. Now let me see. There was information here on the S's part of it, I think, right? Nope. No, there wasn't. There wasn't. And maybe that is where it was first introduced. All right, so that's the going to be important to understand well. Okay, now that's going to be important to understand well. We are going to understand it well. Okay, so. S1 and S2. M is the result of S1 and S2. XA and some K. Choose a random K. S1 is G. And what's S2? Or whatever. This one is GK. XA. Given S1 and S2, this equation with two unknowns. This is an equation with two unknowns. K and XA. Verify knows S1, S2, GXA. So the verification equation is S1 times S2, S1 to the power of S2, YA S1, and is equal to some G of M mod B. Now, G of M, is that something we know as public? No, we know the message. Is public, right? So are we working backwards here? So XA, S1, EK, S2. Sure. So then, okay, these are pretty unique things, topics, but we set up a linear equation where m is equal to s underscore 1 times x underscore a plus s underscore 2 times k. And we can link this. Now, but what is S1 and S2? How do you determine S1 and S2? Recap properties from group theory. So consider P as a prime. No. Let's go with this. Let me see. Well, problem is okay, so according to the textbook, the digital signatures, I guess this is the digital signature scheme. Each user, so say Alice, generates their key Alice signs a message M to Bob by computing a hash of the message to get some M, S, and Q. And the key is relatively prime to so in the signing equation, that's what happens. Now you compute a temporary key, so S1 is equal to AK. So that's the temp key. So there's a concept of temp key. Okay, remember it. Now compute K minus 1, the inverse of K mod Q minus 1. Now you can find that using Euclid's algorithm. Then you compute the value of S2. Wow, okay, so you completely, oh wow, okay. And the signature is S1, S2. Yeah, yeah. You know what S1 is? Because what is temporary key? It is S1. Now the inverse times some message minus x of a S1. And you can do this because yeah, that's the equation that you want to build, and so this is the S2 that you need. Any user B can verify the signature by computing V1 and then V2. A mod Q is equal to S1, which is AK, so YA is AXA, so AXA, AK, XA, AK, or XAS1. And S1 is YA is AXAS1. S2 is S2, but S1 is also just AK S2, KS2. KS2, AS1, XAS1 should equal to M. Yes. Mad. Absolutely mad. Absolutely mad. And then you just got to ensure that these two are the same. Absolutely mad. So any user B can verify the signature by computing this. Okay, example, consider GF19 as chooses XA, so Y is equal to this. Show the calculations for M equals 14. If M equals 14, K equals 7. So we show for M equals 14, we choose a K. Right, we choose a K. So Q minus 1. Eighteen and 7 is equal to 1, yes. Yeah, but you choose a K, which is so out of the blue. I guess that makes sense. You have to choose this K anyway. You just have to. If it's just generated on the fly, like what makes that? How do you ensure that that message is yours? Could this K differ? If it does, then it changes the message, no? Okay, well, say you choose K. Okay. Okay, the inverse. Whoa. Thirteen. And when you verify, you would times all these to get 16. And the message is 16. Well, the message is 14. Mod 19. Message is 16. Is that right? 16. Okay. That's still iffy. Recap required on digital signatures. Here's the thing, I'm gonna just copy this page. And I'm gonna eat in 20 minutes roughly. Slide. Guess you should revise the chaining technique. This is a super crucial page. Love the problem loading page. So A acquires B certificate using a chain, B acquires A certificate using a chain. Now it starts from the one above, you have Z, Y. YV. Why is there ZX if ZX I can't see? X. Z. This is not connected. Okay. Alright, bet. So forward cert, reverse cert. Reverse cert, reverse cert. Forward cert. Forward cert, reverse cert. Now what is this? Reverse cert. Forward cert. Reverse cert. you would need x to w, w to v, v to u, sorry. V to y to v. V to u, v to y. So x to w, w to v, v to y, y to z, z to b. Equals a using z to y, y to v, v to w, w to x, x to a. Okay, now it's most likely going to be examined variations of an L gamma, right? So that's one of the main things that I need to make sure I understand. That is so crucial. Like, without it, I'll be doing shit probably in the exam. So I need to understand this well. Okay, let's see. Let's lock in for the next few minutes. Accidentally clicked stop streaming randomly. Alright, now I'm back for a second. I don't think that ended anything, so we're good. Not bad, not bad at all.
Hello?
Okay. If it's 12 now, I eat, come back, understand this, and then go to the gym. And then come back again, have a shower. Alright. Alright, we'll do that. Because I need to understand this before continuing. Okay, so we're gonna come back to this and understand this, but for now I'm gonna eat and then be right back. So, alright. Play some music in the background while I'm away. I'm back. Just need to restart this so I can get the camera back up. Okay. What's this? Early Feb. Big Four consulting start very early. Considerations. Love Sydney. Yeah, man. I gotta live in Sydney for a bit. We'll see. Okay. Absolute, hello. Good morning to you. Okay. Users' public key is related to their secret key using a one-way function. A signature or tag should be able to create using efficient or public keys that leads to repudiation. Okay, variations of Algamo. So why are Algamo signatures unforgeable? Attacker gets GXA but not X. They can pick this. Need to find values such that solving this is hard. It's computing discrete logs. Yeah. More security warnings for Algamo. Revealing the secret key K for a signature reveals XA. Even reusing K for two signatures without revealing leaks XA. Even reusing K for two signatures leaks XA. Suppose attacker is given M prime with signatures S1 and S1, S prime 2. So that's because S1 is just AK, right? Oh yeah, or GK. Alright, so bottom line, randomness is critical in Algamo and related signatures. So, the thing is, I need to remember that S1, S2, K has to be random. So this is, you have to take this specific link. Okay. So Absolute, I was looking for a couple of study sessions and I found you have ever considered looking, have you ever considered doing it too, like study together on Discord? Yeah, definitely. I mean, that's one thing I want to maybe eventually do at some point. But I don't know how, I guess distracting it would be sometimes, because sometimes I just end up speaking, right, the whole time. And I don't know if people really want to hear me speak. I know I can like mute Discord and stuff, but the also consideration is like, how often will you be speaking on a Discord channel or whatever, versus if it's just on a live stream like this? What would be the difference? What would be the distracting factor? I guess I don't know until I try, right? But I mean, I'm considering it, just don't know how viable it is. Maybe when I'm doing something less crucial, I might test it out, you know, after the exams. That's what I'm thinking. Okay, Schnorr's signature scheme is going to be interesting. Oh, we're going to have so many signature schemes to understand. DSA, so BLS, okay. Schnorr's, DSA, and BLS. Okay, these are all variants of GAML. Now, the variation of GAML here the signing equation okay, so that's a fact, that's a given. Absolute, you'll sign up and wait for that. May do nothing but mutate on Discord and talk, but mute on Discord, I'm guessing, and talk in the stream. Yeah, honestly, yeah, that could be a good idea, right? Just have people in the study Discord would just be muted out. I guess it would also promote a bit of discussion as well when I want it. When I want it. Yeah, it's actually not a bad idea, I think. I just mute out, but whoever joins in, I guess it'll also be more collaborative in that sense as well. So yeah, it's definitely something to consider. Because I do have a Discord and I do have the channel for a study channel. Right, so I do have a studying channel, voice chat. Yeah, I guess I could just mute out, but whoever wants to join, they can just join in. And I guess talks can happen. Yeah, honestly, I might do that. So that's something I might actually do. Thank you for the considerations and thoughtful considerations. Okay, so yeah, you're given some key, you're given some XA, sure. GAML uses the signing equation this, yes. This corresponding verification is this function, yes. I agree, right? I agree, I think. Yes, I do. I agree with that. Other signing equations are possible. Ooh. So that's the whole point. So instead of just a linear equation, you could use some other signing equation. Now, what would that be? Well, you have xa sk s1 equals m mod p minus 1. Well, you could make s2 the inverse of xa. Yeah. Now, do I see the advantage of this formulation? Do I? I don't. Well, what is the positives of using this formulation? S1, S2, S1, S1, YAS2. Very interesting. And what is this variation though? Whoops. Nishant. I focus on side quests and projects in college and got 5 backlogs for not focusing on course syllabus in second semester. Should I clear those backlogs or keep focusing on projects? Well, you kind of got to explain to me what a backlog is. Like, are they assignments in college? Reappears in exam. What do you mean? And Vim Dev. What you mean? I mean, yeah, Algamel, a variant of Algamel might reappear in the exam. Nishant, yes. Assignments, okay. So then my thinking is, I would say just clear the backlog of assignments. You don't want to get into a hole of not doing any of them, right? You want to balance things out, and if you're focused on side quests now, you can still put it on the back burner as well for a little bit until you can finish all those 5 backlog tasks. I would try and finish those backlog tasks if I were you. But that's my opinion, you know, that's how I've dealt with my side projects. You know, my scheduler app that I'm building, I'm only now starting it up again after the semester has almost ended. Because I started this like before the semester started. Now I'm coming back into it almost when the semester has ended. So you can tell from that I would prioritize my 5 backlogged assignments for sure. Okay. Now, okay. Now I will say, okay, finish this whole lecture and then I'm going to the gym. So more details. So considering P is a prime and generate G for a subgroup of prime order Q as before. DSA signature scheme. It just uses a different signing equation and verification equation. I guess that's the point. Just a different signing equation and verification. RSA is for factoring, Galgamel, discrete log. DSA is other, BLS is C, DH, and pairing. I'm like Schnorr. I think this is worth a revision on the actual William Stallings textbook. Schnorr. Now what is this? DSA. The digital signature algorithm, I'm guessing. Data structures and algorithms. It's actually digital signature algorithm. ECDSA. BLS is another one that is weird. Bilinear BLS signature scheme. Digital signature algorithm. Signature scheme. Okay, Schnorr's digital signature scheme. So as with the Gamel digital signature scheme, the Schnorr signature scheme, based on the discrete logs, the Schnorr scheme minimizes the message dependent amount of computation required to generate a signature. Main work of signature generation Okay. It's a lot of information. Okay. Time to go to the gym. See, take off what we have. Gamel digital signature scheme and variance. Alright, so that was a main concern that's done today. Lunch. Now we do these two. Alright, we will be right back in about an hour and a half. Peace. Well, I'm back. It's funny. Alright. I had my shower, I went to the gym, so we're fine now. I need to check, so gym, shower. I might do a little bit of scheduler development before I continue, alright? So, and on this computer. "30 minutes of this is my plan." Okay. Gonna put it there. Cancel. What is the problem with this? Development. Comdocs. Sneezing a lot more recently. What are you doing? Enthusiast dev, I saw that. This is just me chilling for a bit, you know? Doing something different. This is, yeah, so what is this stuff? This is me trying to see how I can use Galois template for my own scheduler app. So I'm just following some of the more recent updates he's made to the template, which I'm trying to understand and copy over into the scheduler project that I'm building. So this is just a little bit of maintenance, you know, maintenance on my project. Just doing it the right way, as followed by this one person who made Fast API. So this is the guy who created Fast API, and I'm just following his his guide basically. No. Okay, right, it's shift. Then with backend. Docs makes sense. Backend is kind of interesting. Okay. We guys can make a community, just start our startup isn't cool, and we will share revenue when we're profitable. How'd that sound to you? Honestly, we've got to figure out something to build, you know? I mean, for this project at least, this one's a open source project, so I don't know how likely everyone would be down to do something like that, but yeah, that's what I'm doing. But honestly, if we have a good idea, why not, man? You know? We find something that everyone can contribute to in the end, at the end of the day. That would be pretty cool. Now we're obviously going to have some problems here with this choice of domains, because it's not going to entirely work the way we want now. Or perhaps, maybe not. It depends. Let me see this one. How did we do it here? All one dashed up command domain. Does this matter if it's on localhost? If it's on localhost, it doesn't matter for me, I don't think. So I think the way it's currently implemented here is going to be fine. Okay. Okay. You should think of some profitable project and ready to join startup. Alright, got you. If you want, man, just honestly, I could make a Discord. I could make a Discord channel for that, where we can share our ideas, you know, on potential ideas of startup stuff. We'll just make it here. I'm gonna just call it ideas for now. Just chat about some ideas. Share some startup ideas. Perhaps we could build something as a community. I think that's what I'll have here, but definitely something. Alright, so we can all share ideas here. Okay. So this is viewed now. Docker compose override.yaml. Alright, so this is the override file that we will eventually have, and this is the Docker file. Now frontend.env, I guess that's the simplest one to change right now, so I'll just do that. Frontend. Okay, well, I'll just close the whole thing. .env. This. Sure, for now I'm going to Leetcode by. Alright. Head off, man. Do your shit. 8,000. And we'll make this 8,000. Okay. Let's see. So that's viewed. Now the front end readme changes a little bit, so let's change that one. Front end. Nice of you to say that, man. Readme for the front end, here we go. $115. Yikes. Why is this difference? This is different by quite a few things. What is different on this line? I can't tell. Doesn't matter. I'm gonna go view the file. Copy the raw. We'll just go back. Reload. Front end, readme. That's so confusing. There's so much changed in this file, so we will have to see. Ooh. Wait, why is that? I think that was a mistake that I had in the past. I think having that is fine. Calling it front end is fine. Okay, done. Alright, timer is done. This is 30 minutes already. That was quick, too quick. Now I kind of want to just finalize this, so I will finish just these last two parts before I call it quits. Now I'll close a lot of these tabs and reopen now the Docker Compose override. Now I'm pretty sure I can just view file here and copy this. Restart, refresh. Where is NeoVim? You're still using VS Code? Yeah, for this I am. I'm using NeoVim for Leetcode mainly at the moment. Just actually not even using it that much, but you bet I'm getting back to it. At least after exams. Right now, I just want to use my mouse and keypad. What can I say? Damn. Does it really matter? I could just at some point I'll have to revert these changes. Just because I would probably rather a subdomain. Would it be worth it? Ugh, you need an enterprise account. Probably not worth it. It's fine, making do is fine. Probably good this way. Now this. Yeah, this is gonna be interesting because it's gonna be a dash. I gotta check my Cloudflare for a second. Hmm. Hmm. Interesting. It's not even on my domain. How does that work? How's that even working? We can get rid of some of these older ones. Alright, I'm gonna say it's not even there. Yo, just finished up some homework. How do you feel about Chrome removing uBlock origin and ad blockers? I don't like it. I mean, they can do what they want, right? I'm not using Chrome anymore. But yeah, I'm not a fan. Because I don't see how this fixes anything for the consumer. All I see it as is a way to lock down on functionality that developers could be using, right? So it seems anti-consumerist and anti-developerist, I guess. What browser do you use? I use Firefox. Yes. And hello there, Denial. Joe Farts. I'm new to coding. You got any basic advice that could help me a bit? I would say like, you know, if you're new to coding, try, I mean, it depends on, are you learning a specific language? Because if it was one language I'd tell you to learn, it'd be Python to begin with, and then learn C next. And then once you have those two understood, you're good to learn every other coding language. Yeah, or, okay, Leetcode Python Basics course, perfect. So literally learn your Python well, then move on to say C, and then the C syntax is mainly used, it is used widely in other programming languages as well, like JavaScript, like C++ obviously, maybe C#, I don't know, I haven't used C#, but I know C++ for sure. You can definitely just, you know, think about that. Hello Raja. Okay. So, okay. Yeah, what Discipline said also, like learning C is helpful for learning about pointers. Now pointers you don't need to worry about too much, but it's a good way to, it's a good thing to understand when you get to it, right? So it's not hard to understand. Yeah, maybe it's a little bit hard, but it's not that hard, all right? So don't feel like overwhelmed when you first start. So Joe Farts. So Denial, how important is it to gamify the learning process for coding for technical interviews? Well, I mean, to gamify it is pretty easy. So I would reckon, you know, if you're doing Leetcode, right? If you're doing Leetcode, they do it well with making those green successes or whatever it is, green accepted. Those are pretty gamified already, I would say. But I would say the gamification of things in general is a good thing to have if you can find it. Chug caffeine spam Leetcode super gamey, yeah. Joe Fatso, I need to change my name. That sounds ridiculous out loud, Lamau. Alright, well it's fine. Don't worry about it. I'm legit just gonna keep on saying it. It's fine. Okay. Now. I'm super close. Vite API URL. Super scary. I guess the subdomains are already handled well. It means then, okay. Even the dashboard is going to be a dash in front of it. And there's no certificate resolver. So we're going to comment this one out. Double checking. So this is indeed, yes. Okay, and I need to return. Okay. I think that would be the final changes. Okay, we're just gonna most likely commit this. we're gonna see how it works right now, just to make sure it does work to some extent. So to do that, we're gonna run docker compose up the, I guess we're gonna pull it down, the existing stuff, and even remove the volumes. And we're just gonna go up D. Now, maybe we'll go up, so we can actually see what's going on here. It should work. Yo, what's all this? Healthy, okay. Love that there's lots of debug information, except I'm scared of seeing all this noise, which is bad. But now I can try going to the different endpoints which are located from the README, and that would be, let's see, the README of the deployment. Go to file directly, scroll to the bottom, and since we're using the defaults, yeah, so those are the URLs of the existing. Now we have the development. So if I scroll to the bottom here, we have the development URLs. So theoretically, this should work, which it does. Alright, so I can log out. Demo at example.com. Password demo. Okay, well that doesn't... Is that not working? Is that not connecting to the back end? Well, we have to open up the console. Now the console, how do I open it up? Control-Shift-J, maybe. That open up Notion. Never mind. Let's see, more tools. Web dev tools. Now, what's the problem here? Cross origin. Okay. Now, that's obvious because the domain name is not the same as what's being used, I suppose. Maybe it's fixable. Whoops, I did not mean to do that. Never mind, we'll go up again. Okay, and we can just have a look at each of these different URLs. So let me restart this. Alright, that's working. That's working. Redoc is working. Adminer is working. Config UI is working. Now, the development URLs for localhost is a different problem. That wouldn't work obviously, but it wouldn't. That wouldn't work either. It's our problem. Yeah, that's definitely a problem. This is file of your color scheme selection. It's called Cappuccino. This is loved by a lot of people, I would say. Now, dashboard dash localhost, API dash localhost. Now, if I do change this to the dashes, that could work. Maybe. We don't know. Development. We're saying it's dashboard dash. Yeah, dashboard dash, API dash. Yep. And in the development URL, that's what it's gonna have to be as well. However, that means we have to point both dashboard dash local host and API dash localhost to, let's see, what was it before? Well, actually, no. What was it before? Deployments. The before was, yeah, so it wasn't, it was just the local host. So I'm gonna have to make a subdomain for API or dashboard dash localhost and API dash localhost. Oh, you've been using regular dark mode for the longest time, I see. For sure, man, get this. Cappuccino is the name. It's like cappuccino, but it's cat, and then poutine. Okay, well, here's what. I know this won't work, right, at the moment. So let me just make sure that localhost works. Yeah, I said that all of these open up correctly, but the front end doesn't really talk to the right thing. So I'm just going to close these tabs. Whoops, close the one tab that I wanted. More tools, web dev tools. Vector. Demo example. Demo. Yep, so that can't access that endpoint. But I don't know why it shouldn't. Especially when I've set the .env file to that. Unless it's just not dealing with that at the moment until I rebuild, which could make sense, so I'll let it do that. However, Discord message. Is yours the mocha? I think it is, but I sometimes use interchangeably between a few. I think it's the mocha, so I use it for, I try actually to keep it consistent. Yeah, like even in Obsidian, it uses the same color scheme. Obsidian. which I think is the easiest one for me to check up on. I say that, and then this will take me longer than the other alternative. Yeah, it is the mocker. Yeah, it is the mocker. Put this in your next stream. Question is, man, it loads forever. How long is it? Khan Academy. Okay, fair enough. I bet. I will. Oh, and we got peeps joining. You know how it is. Alright. Now hopefully that's I can reset this and type in demo at example. Demo. Yay! Now we've signed in. Okay, that was because we needed to rebuild because the end file in the Docker Compose wasn't the same .env file that we're using. Okay, that is cool. That is cool. So that part works. All of that part works. Now it becomes a matter of trialing the other alternatives. So in the deployment, damn. This is where I might need to change it also. So this is the .env file. Right, so so this isn't that env, it is the env of the outside. So if this was instead this. Okay, and we did a Docker Compose up a build. Actually, let's not build. Let's just go up. I wonder. I really do. Does this still load? It does. Let me think. How does this make sense? Alright, let's go to the back end. What language are you coding? I'm not coding a language at the moment. This is just docs I'm trying to read through. Oh, actually, it's I guess what you saw before might have been a Docker. It was just in YAML, the YAML language. Okay, so I should expect to be able to open this page. And it works. And it works. Now this, on the other hand, wouldn't work. And this, on the other hand, wouldn't work. This wouldn't work. This wouldn't work. So we need to do something about that. Animal Rai, how old are you? I am 21. 21 at the moment. So if that doesn't work, we will need to create some Cloudflare endpoints. Sorry, just DNS records. So we had a DNS record for localhost. Yep, now we need one for dashboard. Localhost. Oh, this will change the front end. Yeah, this will change the front end. Fuck it. We're doing it anyway. Okay, we add one more record for API-localhost. And we use the same loopback address. Now if I control click, maybe. It's kind of weird. It's actually just not showing up. If I cancel, maybe just go up again. Oh, hello Deb. First, I don't use the code for such long sitting, but after seeing you, also started to 6 to 8 hours in one go. Alright, well, I will say, right, don't actually sit for too long. It's bad for your health. You know, I do stand up and I do have a standing desk here, which allows me to stay on this for so long as well. Alright, so, but good regardless, you know. It's good that I'm being able to influence you in a positive way. You know what I mean? So thank you for telling me that, Deb. No, these don't work the way that I want it to. I need to like clear my cache or something. I'll try copying this URL directly. Control C, Control V. Okay, that's not it. I'll just type it in, I can't be bothered. I can't be bothered to copy and paste, and I'd rather type it in. Kind of not the right way to think. Okay, well, looks to me that there's something wrong here that I just can't figure out. More tools, web dev tools. Why doesn't this just load? Forbidden. Forbidden? Forbidden. Not found. But this is forbidden. 403 forbidden. Why? And where is it originating from? Cloudflare? I mean, the fact that it's not even... No, it is reaching the proxy. It is reaching the proxy. Right? Or not. It might not be. Which is sus. Okay, right, so it could reach if I went localhost. That is reached. But it's 404 not found. Now if it's API-localhost, you can't find anything. Let me go to traffic again, just to have a look. Services. API at internal. API. Routers. Okay. Dashboard, adminer. Now adminer localhost. You're telling me that should work. Are you also telling me that if I go to localhost dot just go to that wouldn't be found. However, 5173 could be? It is. What about the backend 8000? It is. Okay. Do I want to just use this instead? So 8000 docs. It is. Redoc. It is. I could just use this for the time being and not use dashboard dash. Will you deploy this app? This app is already deployed. That's why I'm kind of like doing stuff now for it. It's deployed right now, but yeah, on the next update, it's gonna be a little bit wonky because yeah, I just want to make sure it's not wonky. So this is the app, right? And right now, if you go to this link, the staging link, you can use this app as is. So it's deployed already. Now I just want to make it continuously deployable. And that's my whole goal. That's my whole goal with what I'm doing right now. And so, you know, this scares me a little bit because We go to deployment. If I was deploying staging, then I need to have dashboard staging project. So the front end is going to be at dashboard staging and dashboard scheduler. So dashboard staging scheduler, it's also going to be at dashboard scheduler eventually. So that's something to think about. Okay. Something I got to think about. But I want to call it just scheduler at one point, right? Instead of dashboard scheduler. So, you know, I might just remove the term dashboard in the future and keep just staging scheduler. Is that okay? Let me think. Yeah, it's a matter of me trying. Can we contribute to this project? Of course, yeah. So that's the thing, this app is open source, so anyone can just come in and help out. Alright. Now, you know, what you want to help out, obviously there are some issues right now that could need help on. And there are also some pull requests that you can see are currently occurring. One is from another guy that hasn't done much ever since the 5th of August, but yeah, this is what I'm doing right now. The thing is, you know, some issues, if you want to create an issue, of course you can create one as well. Now, the problem that I currently have, is I don't want to deploy it like this. And these names have to be changed. Whoops. All right. And the API, yeah, it's unfortunate that I can't do it, but we'll keep it this way for now. Do I need I want to try opening it up on Chrome maybe. So HTTP, okay. API localhost David Shah me dash 403. However that works. And this works. Maybe I'll keep it just like this, man. Still unfortunate. And then what? If we change this, do we have problems? Yeah, look, when this eventually gets deployed, we're gonna have issues anyway. But for now, we're gonna call it good. Yeah, we know that dashboard and API might fail on us. And eventually we don't want to just have dashboard and API. What though? Staging. Yeah, you know what? I think I will just remove dashboard and API straight away. No, I won't. Keep this as is. But and then we're gonna make a change here. Should we? Action, hello? Would this be alright? At least we don't want dashboard. At the very least we don't want dashboard. So I might just remove it. Every mention of dashboard. Is it? Let me think. I don't know. Alright. We'll keep an idea. We'll keep a thought on this. Alright, we'll keep it on hold for now, but we'll come back to this. We are gonna oh, hello guys. Thank you, Menace. So yeah, I gotta write this down. What is this music called? Right here. Literally whatever is on a lo-fi music. Yeah, the go-to, the classic. Okay, now I need to provide the commit ID. I gotta remember. Now this is all a lot more complex. But it's part of the work, it's part of making it right. Let's see. There we go. Okay, I'll revisit this problem. In the meantime, we'll cancel this. Go back to notifications. We can mark it off. And that means we can continue with the rest of the stuff without any worries. So we can close these tabs. What's this one? That's fine. It's fine. Close. Okay, eventually we just have this open. Alright, now let's close this, turn it off. And we'll come back tomorrow to do more of this. Just shut down directly. What do we have? Alright, hell yeah. Had to join up, Joe Farts. Thank you for joining. I think you sent me this, so we will accept. Okay. Now the scheduler, we can close this and get back to here. All right. Oh, Jacob, so how well did you memorize your... Hold on.
Oh.
Alright, how did you memorize your stories for your Amazon interview? Or how well did you? I'll give you the synopsis, but I also streamed it all. So there's a playlist on my channel called My Amazon Interview Process, I think, which you can check out. But also, how well did I memorize it? I think, you know, I had the star framework set out for all of these stories that I had, and And literally in the interviews, I told them that I might be reading from some of my notes, right? So I told them, you know, I might be reading through some of my notes here while I answer these questions, and that was fine by them. But I did, you know, have enough of a familiarity with these stories that I was able to, just from, say, reading one sentence, I could elaborate a little further, right? So look, at Syncytium, we faced a development-wide issue with our Docker images, which were too large, leading to slow deployment times and even slower development times. The main reason was because these Docker containers had, so this is me like talking as an extra sentence, these Docker containers had too much data within them. So these images that we created had unnecessary data, which we could have just included the build files in, but we didn't. We had the whole code base in those images, and that was a contributing factor to why it was slow. And then I would go with the T, and then the A, and then the R, right? But I was able to elaborate on each of these single sentences because I know the story that I am talking about, right? I kind of, you know, they're not made up. That's what I can say to that, Jacob. Let me get some water, I'll be right back. I might comb my hair a bit actually, it's also getting a little messy. Alright, give me 2 minutes. Yeah, awesome, Jacob. Also, I mean, if you're still here, keep me updated too. Just want to know, how you go. And best of luck. Okay. Now we should have. Okay. These problems. Oh, camel signature. Okay. Oh, prime fields again, I guess. I'm still gonna remember that. Let's see. Let's just close some tabs. I need to do this. So practice polynomial rings. Mm-hmm. I can watch this. I will watch this. I'll watch this later, to be honest. Probably remove this. Want something here. That's fine. Polynomial rings. That was magic and fast. Seems like you are another man now. Wow, this is an advance on that. Oh, right. This is an advantage, I guess. Yeah, I mean, I just combed it. Alright. That's gonna be difficult. Okay, thing is, best way to learn about these is just through practice problems. So anything that I don't understand, easy. Go through practice problems to understand. Cool. Now, We'll open it up. Gonna just make it low brightness. I'll probably let it finish loading because it's probably gonna sync. Once it's finished syncing though, look, math tasks week 9 or worksheet week 11. Let's see what's here. Yeah, this is the page that I need. This is what I need. I need worksheet week 11. I gotta like turn off auto brightness on this iPad. It always changes and I don't like it, actually. Appearance. Wait, can you not automatically change the brightness? Oh man, that's too kind, man. Absolute. You're too kind. Bright. Okay, how to stop auto brightness? iPad. Accessibility, display and text size. Accessibility, display and text size. Auto brightness, here we go. Okay, now we can just adjust the way I want. Yeah, true, never stop making lives. I can't guarantee that. But I'll be here for a time. At least for another year. With my masters and all. Would be cool if I can get into my day job and also work on streaming as well. Would be nice. What's the difference between GF8 and Z8? Is the set of polynomials, or Z8 is the set up to 7? So let's make this year a special one. Exactly, man. Exactly. Absolutely. We'll make it extreme output. Okay, GF8. Right, so that's something I gotta understand now. GF8. Problem is, how do we get to there? How do we get to that? We can zoom here. So this it says week 6, but it's definitely not week 6. It's like week 9 content. Okay. Sad that the I might need to refresh the side bar because the chat isn't reloading. Refresh cache on current page. Okay, I just did a full nuke on the left chat, but hopefully that means it sends messages now. Right. You have 2 monitor? I do, you know, I have a smaller laptop here, and also have a bigger one which I am sharing my screen on. Mm-hmm. Polynomial rings. Where do we get first introduced to GF? Here we are, GF. Okay, so it is formally represented as the set of all residues of polynomials. All residues of polynomials in GF. P x obtained when divided by prime polynomial mx of order k. Yeah. Sure, that doesn't make sense. But you would have something like this. You would build out a table like this. You know, we'll say like, this is the table that we eventually have to build out. So we will. Complete the missing entities in the table. Okay. Okay. We're gonna try this question. Okay. Use the irreducible polynomial x or plus x plus 1 to create a table for the finite field GF16. Two important things, I guess, variables. GF16 is important. polynomial, irreducible. You're always going to be given an irreducible polynomial. To create a table for the finite field GF16. Now GF16 is going to be interesting. It's 2 to the power of 4. So, you know, looking at this GF, to the 4. If you have I is negative infinity, xi is 0. As polynomials, it's 0. And as vectors, it's whatever, but multiplicative order is interesting. That's also a problem that was asked. Understanding these hosts will also be helpful. I'm gonna stand. Okay. Polynomial rings. Okay, this book doesn't have any of that. So thinking, how can you get, say, x4, or how did you get x? Oh no, that makes sense. Now, how do you get x4? We can keep this on the side. x4 is going to be, wait. I guess the question is, how do you get 3? 0, 1, 2. It is 0, 1, 2 is, yeah. And 3, 1 plus x, but how do you do that? X to the power of 3 is just x to the power of 2 times x to the power of 1, which gives you x plus x to the power of 2, right? Not exactly. Now, this is divided by the irreducible polynomial 1 plus x plus cubed. Okay. Let's see that lecture. Wait. Might be good. Let's watch this. I'm gonna pause that. Yeah.
Several times we've mentioned the ring Rx, which is the ring of polynomials with coefficients that come from the real numbers. We can do a similar kind of thing if we start with any kind of field. So let's say that R is a commutative ring. Now, we're not using the real numbers here. It could be, but really this is any ring in general. So we're going to say the ring of polynomials with coefficients from this commutative ring is basically exactly what you would think. We're going to say it's all things of the form an x to the n plus an minus 1 x to the n minus 1 all the way down to a1x plus a0, such that all the ai's come from our commutative ring. Now, if we do that, addition and multiplication in this thing are going to be exactly what you think they're going to be. Rather than trying to do it in general, let's take a look at a specific kind of thing. So if I have z2x, that's going to be the set of all polynomials like this where our coefficients are either 0 or 1 because they have to come from z2. So I might have something like an element of that is x cubed plus x squared plus 1. And if I want to take that plus, say, x to the fourth plus x cubed plus x plus 1, we're going to add just like you would think. However, because we're going to be adding these things, we're adding them the coefficients from z2. So I only have x to the fourth. But when I take 1x cubed plus 1x cubed, that's 2x cubed, but mod 2, that's 0. That comes out. We only have a single x squared. We only have a single x. But when I do 1 plus 1, I'm adding in z2, so I get just x. Similarly, if I have something like x cubed plus x, and I'm going to times it by x squared plus x plus 1, I'm going to basically FOIL it out just like you would in a normal thing. So we're going to have x cubed times x squared is x to the fifth. X cubed times x gives me x to the fourth. X cubed times 1 gives me x cubed. X times x squared gives me another x cubed. X times x gives me an x squared. X times 1 gives me an x. And then when I combine like terms, once again, I'm adding them, taking the coefficients in z2. So x cubed plus x cubed is going to give me 0. And this thing is x to the fifth plus x to the fourth plus x squared plus x. Let's do it again, and let's maybe go to, say, z4x, so we've got things that aren't just binary. So now my coefficients for my polynomial can be either 0, 1, 2, or 3. So let's say I have something like 3x cubed plus 2x squared plus 5. And if I add 3x cubed plus x squared
Yes,
plus
I get the mods here.
2x plus 2. And actually, hold on, I said plus 5. That doesn't exist in z4x. I can do plus 1, and that'll work. 3x cubed plus 3x cubed. Normally it would be 6x cubed, but we've got to do things mod 4, so it's 2x cubed. 2x squared plus x squared, 3x squared. That's perfectly fine. There's only a single x, and 1 plus 2 gives me 3. All that thing is fine, mod 4. If I do 3x squared plus 2x plus 3 times a 2x plus 3. 6x cubed would really be 2x cubed. We'd have 9x squared would really be just x squared. We'd have 4x squared, which is just 0. We'd have 6x, which is 2x. Another 6x is another 2x. 3 times 3 is 9, which is really 1. And again, 2x plus 2x, 4x is actually 0.
4x.
So this would be 2x cubed plus x squared plus 1. So again, any commutative ring that we start with, we can go ahead and create these polynomials from it, and they work pretty much the way we would expect. Now, one interesting thing is this works for any commutative ring. We can create this ring of polynomials, but if we start with an integral domain, which again means it has a unity and it has no zero divisors, then when I create the ring of polynomials from that, then that is also an integral domain.
Yeah, that's beyond me.
For the most part, it just follows pretty immediately. Because D is an integral domain, it has to have a unity, and that unity, just taking just that thing as sort of the constant of a polynomial and having no terms with x's in them, that will work as a unity for your integral domain, for the d of x, for your ring of polynomials. Similarly, just because d can't have integral divisors, when I do this whole multiplication process here, I can't have any polynomials that end up being zero divisors. I can't get all the terms to cancel out because I can't get the individual things to cancel out.
Right, let me understand the textbook here. So, polynomial rings with finite fields. We have learned the properties of numbers mod n that are sufficient to understand many modern and classical cryptographic primitives. Right, let me take this off. How much percent is this? 1%. What about this? 9%. These cases need charging. Be right back. David Thompson. What are you studying at University of Melbourne? I'm studying Masters of IT, specializing in AI. And this semester I'm learning cryptography and security, computer vision, and AI planning for autonomy. A set of polynomials over a field f is denoted fx. Are equal if the coefficients a polynomial of degree n is monic if its leading coefficient fn is equal to 1. So this is not monic, however this is monic. Hello, Aryan. Welcome back. Axel, hello. What are you doing? I'm trying to learn polynomial rings. Exam revision. How's your day been till now? Pretty productive. I did Leetcode. I solved the problem without looking at the solution first. It was a backtracking problem. Then I spent some time learning about or revising about modes of operations, greatest, no. Algamo and the Algamo digital signature. And now I am trying to learn polynomial rings. But even before polynomial rings, I was learning. I went to the gym, had lunch, had a shower. So yeah, pretty good. Pretty good. "29th, so Saturday, Sunday, Monday, Tuesday. Sunday, Monday, Tuesday, Tuesday, Tuesday. 12:30 p.m. Tuesday. Okay. That's the date of my exam. Let's close this. So adding is simple. When you reach 3x, then that becomes 0. And 4 just becomes 1. Yep, so the product two polynomials is another polynomial in fx defined by this, where now the 3 there is not necessarily the 3 there, which is fine. But 1 times 1 is 1. X times 1 is 1. X times x is x squared, but 1 times x is 2x. And there's only ever one x squared. Only ever one x cubed 2x cubed 2x cubed plus 2x4. Yeah. And this is all in 3, which makes sense. So that's no confusion there. I can get rid of this. The set fx together with the above two operations form a ring. This ring resembles integer ring in many ways. How polynomial rings are different to integer rings. Why are we dropping frames? You know what I mean? Let me try and just refresh. Okay. Quit Firefox, reopen. Reopen. Yes. Alright. is of infinite size. Hmm. What's a characteristic? Let P be a prime. ZP is a prime field. Consider polynomials over ZP.
Yeah.
Okay, maybe. Give it a break on this. On this one. Fine, I will do this. That'll be best. Do a little bit now, makes sense. All right. Mm. You're happy with that solution? Okay. This would have been on Tuesday. Let's work backwards. 1, 2. Three, 4. No. One, 2, 3, 4, 5, 6. What's causing the drop?
Now let's say, now your question. Papers in the middle of the... All right. Okay. As you can see that let us, so we are interested in, hello, sorry, I'll just see to it that it's all recording.
Oh, hello, Ditcher. How do you take notes, bro? I just take them. Let me think. Every time you write a new like annotation or note, it has to be somewhat new information, right? You can't regurgitate stuff. So for me at least, I don't write notes beyond what I have here. I'm not regurgitating, I'm encoding. So there's a little bit of a difference. You know, say the essential idea of our Gamel signature scheme is to verify linear equations. That is encoded in my brain. But writing it out keeps that structure neat. Anything that's written here should be encoded in my brain. Some, at least the stuff that's written in the revision lecture section. So everything previous here, these are all questions. I won't remember them all, but these parts I encode into my brain. All of these. Now this is mod 5, right? No, that's the remainder. What becomes x to the 7, dude? Oh, I'm doing the wrong thing. Again. No. Okay, I'll just write over it. 12x5 is 2x squared, 2x to the 2x5. Why does I keep on going back? Yep, 2x5. 4, it's only 1, so x4. Plus 6x cubed, we have 2 of those. So 10, 10, maybe none. So no x cubes. X2s, we have 5, so it's also no x2s. And x 4x plus 3. That should equal to it. Yep, it does. Okay, good, perfect. Hmm. 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 Hmm.
要做什么好吃的？
Joe Farts, hello man. It's 5:30 now. I think dinner's about to arrive, so I might be eating soon. It's 1:30 a.m. But it was late for you too. Nah, not that late. Lights, literally the window, the light shining on my face right now is from the window here. So yeah, just thought it was an actual cloud. You're a funny one. Okay, convince yourselves that 1 plus x cubed is an irreducible polynomial over f2. Try dividing the polynomials of degree less than or equal to 3. Try dividing the polynomials of degree less than or equal to 3. So what, x squared? We just did x3, by the way. I want to try this actually a little bit. Yep, so cannot find a smaller polynomial that divides it. Well, yeah, let's verify that. The thing is, maybe you can think of x cubed plus 1 and 1 plus, okay. X cubed plus x plus 1. X cubed is just going to be 0. So we just say 1 here. X cubed minus plus 1. It's just plus 1. Just x. Now, if it's just x, man, I get it. Okay, I get it. Yo, what's happening? Yeah. Took me some time, I'm getting it. Okay. All right. Now, what does this necessarily mean for us? Yep. That it's irreducible. You can just think of it. You can't really prove it. You only can do it by brute force, kind of. So you're always just going to be given an irreducible polynomial over something. So GF 2 to the power of 3 GF2x mod 1 plus x cubed. All right. The table of elements GF8 is given in the next slides. Is that meant to be 3, or could that just stay as is? It's possible to just stay as is. There you go. What happened to the camera? Just lift it out for a bit. Okay. Hold up. 好吧。Mango. Mum wants me to eat mango. I'm way too spoiled, man. x0. It's a prime. Okay. Convince yourself that 1 plus x plus 3 is an irreducible polynomial, yeah, which is a prime polynomial, over f2. Now it's over f2 because, yeah, you got 1, 0, 0. Try dividing the polynomial, blah, blah, blah. Okay. Now GF2, 3. Galois field, I think, is what it's called. Galois. Mahidha? Hello? Oh, okay. Let me turn up the volume. Love to see it. It's just a slow transition in.
Galois. Galois.
Oh, wait.
Galois.
Galois. I'm gonna say Galois field. Call it GF. Oh, it's the remainder. Hmm. Multiplying x to x minus 1. X cubed is x squared times x. X squared times x, should it not be? That's the confusing part as well. There's a remainders. Sheesh. X cubed with X. X to the power of 4. Okay. Minus X minus 1. Is that really the remainder here? Well, actually, minus X. Because it's a mod 2. So it's just X plus 1. Zero, 0, 1, 0. Zero, 0, 1, 1. I think I figured it out, like I understand it now, but problem is I misunderstand multiplicative order. Thing is also I can understand this probably in a minute, in a hot minute, in a hot second, you know. In a hot second I'll be able to understand this so well. Thank God I'm getting through this. Slowly getting through this, understanding it. X plus 1, yeah, I got it. But what is multiplicative order? Yeah, alright, so this is the problem that I will have to ask. multiplicative order. First, understand what is the multiplicative order of A mod n. It is the smallest positive integer k, such that ak is equivalent to 1. In other words, it is also the number of elements in the multiplicative group generated by A in mod n. Then you can use either way to compute it. Man, what are you saying? What are you saying? In other words, it's also the number of elements in the multiplicative group generated by A in mod n. Oh, right. Yeah, multiplicative order. Hmm. Yeah, that's so good. How does that work? There is no multiplicative order. Interesting. Well, 1 times 1? Now, what's A? Let's say A is is it relatively prime? So if you had X, the remainder should be 1, the greatest common divisor. Okay. Hmm. If it's 15, it just means, say, x is relatively prime to no. Akshit, hello? Oh, what the hell? The messages are popping up again. For some random reason. It wasn't before, now it is. Seems. So for x squared times itself, what laptop is this? 谢谢吧，没事，你不用叫。Yeah, so this is a MacBook Air so this is a MacBook Air M1. You're literally selling your M1. To be honest, I think someone literally just bought it, I think. That's so funny. This M1 probably lasts like one more year for me, to be honest. Or could be less, to be honest. Over the summer, I might find that a better computer is just going to be better for me. The procedure tutor did, but you do not need to do so. You can easily check that x squared times x squared is x4, so you no need to compute. Just check the table. x4 times x squared is x6. x6 times x squared is x8. x8 times 10, 12, 14, and x14 times x squared is x16. It becomes 0, so then does it become 0 or does it becomes 1? Cubed. It is by definition how many times you times it. So for x2, you do 1 x4. Oh, hello, copy multi. Oh, my camera's out of focus again. Why, man? Why? Can't get it to focus. No, doesn't work. Doesn't matter. Don't matter to me. Actually, I'll just pull it up a bit. Absolute holla. Hello, hello. Once again. So it is by definition how many times you times itself would get back to the value of 1. I would say go to the power. I would say go the power with value 1, find the power number, which is 15 in this case. I think this works. Whoa. I gotta eat soon. Alright, I gotta eat right in a moment, but I need to figure this out. I need to fully understand this. Hello, Shivang. Cubed. Cubed. 9. So 5 is 3. 6 is 5. Shit. So if you multiply x to the power of 2, you will eventually get all x to the power of 2. X to the power of 2 and up to x 15. Just because x16 is x1. Right. So then, if you have x 2, x 4, x 6, x 8, x 10, x 12, x 14, all the way to x1, x 3, x 5, x 7, x 9, x 11, x 15, x 2. Which means it has total 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, wait. 1, x11, wait, x13, x15, x15, wait, One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1, 2, 3, 4, 5, 6, 7. I mean, not power. But x1 is equal to 1. I see. I spelled savior wrong. The value or as polynomial. Alright, I'm gonna go eat dinner. I'll be back in about half an hour to 40 minutes. Alright. Cool. Alright. I am back. Now, I'm trying to understand these multiplicative orders still. But I can reason about what it means. So, when you start at 1, you start at x2, if you start at 1, you get to x2. Four, 6, 8, 10, 12, 14, 15, 1, 3, 5, 6, 5, 7, 9, 11, 13, 15, x2. I really almost want to do a second Leetcode problem, but nah, I won't. I almost want to do it. Okay, we'll say we'll go to 8 tonight and prepare to wind down. Yeah, we'll prepare to wind down in a bit. So this question is going to be hard for me. Question is hard for me. But I understand it. Let me do one more of it. One more part of it, which is x5. Man. x4 plus x plus 1. Now, it'll just be x. x5 minus plus x squared plus x minus x squared plus x. Now, if it's x squared plus x, that goes into the next spot. Yeah. So x squared plus x gonna be 0, 1, 1, 0. 0, 1, 1, 0. And you say 3 multiplicative order. 5, 10, 15. And you're at 5 again. 1 by 5. But what, it goes to 5 again? Okay, I think that's fine. Well, so finite field of 9 elements. So convince that it's irreducible over F3 to the ternary field. The computations run on similar lines. Oh, hello George. Nice keyboard. I was thinking about getting the glove, but went with the ZSA Voyager. Yeah, fair enough. Voyager is still a very good choice. You know what I mean? Yeah, like my friend got the Voyager as well. At the moment, I've only been using it for Leetcode problems, but definitely want to use it more in Vim, but haven't been using Vim recently. monkeytype. I want to do 1. I'll do 2. Hello. I want to change this to Python now. What's Python 5k? Hello? Python 5k. It is 5k, yep. I guess the question is I can ask. I guess it increases variability, right? Damn, bruh. So maybe that's what I need for C++. Oh, it doesn't have it. Alright.
Yes. You done that?
Yeah,
Good, thank you.
you're right.
You make my
Yeah,
life
yeah,
much easier.
yeah. I know. I think I did.
I make your life miserable.
Nah. Oh, okay, so I'm reading text now. Hey buddy, I like the grind. I'm a software engineering student. I've been thinking about starting YouTube for a long time. Any tips? Well, I mean, just start, just do it, and learn along the way, I think. George, so I was using Vim too, but after I switched to Colmac, I was too lazy to change the key bindings. Yeah, that's fine. I didn't know you could practice code typing in there. That's cool. Yeah. Alright, one more. I'm almost addicted right now. Three. 10. Hello? Oh, this is continuing. I'm doing one more. I want to try typing while hovering my hand. What exam are you studying for? I had my Calc 2 midterm. Fair enough. I'm doing cryptography and security at the moment, so just trying to learn, literally relearn something that I've completely forgotten now for the subject. But my exam, like full-on exam, is in 3 days for it. Alright, give me a sec. Turned on the lights. Alright.
Maybe that.
Are you studying CS? By CS being cryptography and security, yes. But no. Well, yes. I'm still technically kind of studying computer science, but I'm doing a master's right now in specializing in AI. And then I'm just doing cryptography and security on the side. Like, it's technically a core, but it's also not related to AI much. Sitting down now. Okay. Does it always have to be of degree K? It feels like it. PK. Okay. Thing is, that's fine, I think. Now I now understand that, so that's fine. The math extension questions for the mid-sem break. Alright, fine, let's do a little bit of that. Fuck it. Might as well. Might as well. Where would that be? Yeah, math tasks. Here we go. Okay. So division algorithm. So this is pretty much all the math revision I could do. I'll try and do as much as we can here. So I think I'm fine just to move forward from this section. We'll go to step 2. Prove the following given. So let A represent a decimal number. Alright, you guys can't see any of this. Hold on. Let me go to it. I mean, I could share my screen, couldn't I? Yeah, I want to try sharing my screen. We'll try it. Screen mirroring to my MacBook. I can't tell if this is working. I think this is. Oh wait, I gotta open it up. I could open it up on my iPad. I could open it up on my iPad. No, I can't. I blocked iPad. I blocked my own iPad. I mean, YouTube. How do I check? I don't have my phone on me. I literally have only a lap. Okay. Ugh. I have a computer here, which I can check. Zero. Okay, that is working. That is working. Okay. Sure. Prove the following. Let A be represented as a decimal number. So by the way, guys, I can't hear any. I can't see anybody's texts. Because it somehow when I present, it blocks the other screen altogether. So I can't read messages. Alright. Let A be represented as a decimal number. Prove that A mod 10 is simply ones placed in the decimal notation of A. Prove that A mod 100 is simply 2 decimal number made up of tens and ones placed digits in the decimal notation of A. Prove that for all positive integers n, this is this. Prove that for all positive integers m, this is equal to this. Alright, well, that is, I'm going to think of B for now. So prove that all, for all positive integers n, so what you're saying, it could be 1, it could be 2, it could be 1 plus 2. So if it was just 1, right, it's just 2 mod 2 mod 2 is 0. Or if you go 2 times 3, so 2 times 3, okay, or 3 times 3, or 6 times 2, 12. Yeah, okay. How do you prove it? How do you do it? I guess you can say you add n plus 1, maybe. So what? 2 times n plus 1 divided by 2. So if it was 1, then it's just 1 plus 1 divided by 2 is 1. Or 2 times, or if it was just 2 is 2. Wait, if it was just 2, 2 plus 1 is 3 divided by 2. Times 2. I mean, n plus 1s, they just get cancelled, and there's only ever maybe you consider if there's odd number of n's, right? If n is odd, then what? N is just n is just going to be, say, 1 or 3. So if it was 3, then it's 4 div 2 is 2 times 4. 2 times 4. I mean, 2 times 2 is 4. But that's definitely also not it. N times n plus 1 div 2. Now, maybe we can just cancel these out to say n times n plus 1. And since it's mod n, then n is equal to, well, then n plus 1, then it's going to equal to 0. Right? Well, we proved it then. We proved it, so we don't need this. Alright, so that's, we did it. Let's see if we can do this one. Double checking. We're fine. Okay. Alright. So what we could do to prove that for all positive integer m, I need to know some math. I need to know my math, man. I guess it's the same concept. Because it's like 2 to the power of 0 plus 2 to the power of 1 plus dot 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 plus 2 to the m minus 1 plus 2 to the m. Right? Which means you can pair them up to get 2 to the m plus 2 to the m plus dot 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 that many times, which is half the time. And so what if m was, so if m was even, then it would just be 2 to the m times, so m times divided by 2, right? But if m was odd, Same thing actually. Is this always true? So what if we had 1, 2, 3, 4, 5? You pair these up, you pair these up. And then the middle one is half of 6. But then that would mean like, what, you have 5 div 2? 5 plus 1. Like, what is this equal to? It equals to 15. Which is still true. So we're fine. So we'll just call this example. Okay. Now what? Oh man. I mean, let's try for an odd and for an even. So this is for an odd and this is for an even. So we'll do an odd first. An even is actually pretty easy. But for an odd, we have to check. Two times 2 to the 4. Yeah, man, why is this difficult? Two to the 0. 2 to the 1. Yeah, okay. You're proving something about maybe this was 2, this was 1. It was 2 to the 0. Now you're pairing these up. So you might say, 2 to the 0 plus 2 to the m plus 1 m divided by 2. Hello, Shah. Good morning, man. It's funny how I'm still here. I'm about to clock out anyway, actually. It's funny I'm still here, and it's funny that during that time you've been asleep, man. Day goes by, man. The sun has risen on your side, the sun has fallen on mine. We live in two different worlds. I'm kidding. Of course. Okay, well, here's this thing. I'm gonna look at the solution, because this is taking me more than 5 minutes. How do I cancel this? I guess that's how. See, where would this solution be? Do I even have solutions for this? Oh yeah, this has to be it. Oh, whoa, I didn't know that. I didn't know that. I didn't know that was the identity. Why? What is this actually called again? So 2 plus 2 to the power of 2 plus 2 to the power of 3. So 1 plus 2 is dot 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 2 to the power of m. What is the sequence called? There's a name. Shoot, man. This is the easiest probably question if I knew the name of this formulation. Which I do recall doing something similar in real analysis, but now I've forgotten the name fully. Thanks, Shah. I mean, the thing is, you know, I haven't been sitting here the full 10 hours, just saying, you know. I went out to go to the gym and then obviously went to eat my lunch and dinner. And went for a shower, you know. So don't want to sit for too long as well. Arman, can I become a web developer in 1 year? If yes, how much I take time in 1 day? I know basics HTML, CSS, and JavaScript. How much time you should spend in a day, right? I would say, you know, as much as you can, to be honest. Like normally when you're studying, it should take, usually can't work more than 4 hours, usually. So I would say try and reach that limit of 4 hours every day, just learning about web dev. If you got nothing else to do, you know, just go for it. Hone in on that web dev skills. You know what I mean? Definitely though, it is possible to be good at it in 1 year. You just got to put in the effort, and you're good. That's what I can say to that. Okay, so the problem was that 2 to the power of n plus 1 minus 1 I don't remember the formulation, man. I don't remember it. Okay. Let's just move on. So inverses mod n, we'll say this is the last thing I do today, because I feel like it's possible to just do this inverse mod n stuff. So we'll be fine. Right. So inverse mod n, oh wait, actually I didn't even finish the top one here. Let a be represented as a decimal number, prove that represent a number in decimal and apply the identities given above. So it's simply one's place in the decimal notation. That problem is pretty weird to ask. Yeah, sit 2 to 3 hours and that's the limit. Yeah. Look, that really is it really is fine just to have that, you know. And you can separate your days to do more things, and not literally just be studying all day every day. Which for me, you know, I'm doing because I kind of want to do more deep work if I can. Like right now, I'm reaching a limit as well. Like my efficiency isn't as efficient, and that's a problem, you know. But I have nothing else to do, so might as well. You know what I mean? Might as well. So let a represent a decimal number. A decimal number. A number with a decimal. Prove that a mod 10 is simply one's place in the decimal notation of a. Like, what does one's place mean? Okay. I kind of understand the idea. Okay. Raja, hello. So, do you have any tips for pushing through when stuck and struggling to understand? Getting stuck can really mess with my confidence and leaves me feeling anxious and discouraged. What do you do when stuck? Yeah, so look, man. The thing is, when I just look at the answers when I get stuck. That's what I do. So you should put a policy on yourself to say you know if you get stuck after 5 minutes, then just look at the solution, because there's no shame in that. You're learning, right? And that's the way that you're meant to do it. You know, even for Leetcode, you know, if you're doing Leetcode and you're stuck on a problem, after you've read the question, of course, and you're stuck on the problem for like more than 5 minutes, just look at the solution. And from the solution, once you see like how they're going to approach the problem, pause the video or pause the solution and try and do it from there yourself and see if you can progress a little bit forward as well. It's like try and use the tips that they give you. Spend however much time until you get stuck for 5 minutes, and then look at the solution again and then repeat. So that's kind of the policy. If you get stuck in 5 minutes, if you get stuck for a full 5 minutes, just look at part of the solution or the whole solution if it's just really that simple. Okay? There's no shame in it. There's really no shame in it. Like, if anything, look, like I'm doing this on stream all the time. Nobody's called me out on it. You know what I mean? Like, I'm looking at the solutions right now, but I haven't even done question 8. And nobody's called me out. So there's zero shame. Obviously, like if you don't have solutions though, right? So if it was like an assignment and you didn't have solutions, it's really good to just speak to your friends about it. So if your friends are also doing the same assignments, just ask them, hey, I'm stuck. What do you think about the problem? Just wait for their response. Or if they don't tell you, you can also just think about it later. Move on, right? Don't think about the problem anymore. If you're stuck, just move on and then go to the next question. Now maybe you're stuck on the next question as well. Do this until you've gone through all questions, and then revisit the question that you got stuck on. All right, you have to revisit that. All right, because if you don't, then what are you learning? All right, so for me, at least, I'm going to revisit A, which I'll make a note of. Oh, good, Raja. Okay. Damn, okay. Find multiplicative inverse of 43 and 100. Can I be bothered, man? I want to call it a day. I'm going to just call it a day. I'm calling it a day. Alright, because it's I already spent quite a lot of time today on this. 11 hours probably now in total. We'll just finalize this day by planning out tomorrow. Alright. So these are the tasks that need to be done for tomorrow. We learned quite a lot just today about a few concepts again. So digital signature schemes for Algamel and its variants. So mainly the main part of that was learning about how the Elgamal crypto system has an encryption equation and a verification equation. That's the main part of Elgamal. Now the thing is, I need to look further at polynomial rings. So I did learn quite a bit about polynomial rings today, and I do like that, but that did take up quite a bit of time. So I will say almost an inefficient amount of time. So that's something to work on for me personally. But in terms of tomorrow, you know, what are we going to be doing tomorrow? We can organize these just to see. So since I only have a few days, literally Sunday, Monday, before I have an exam on Tuesday, it's probably good to finish the exam tomorrow, 100%, finish the math extension problems, and ideally also understand MST solutions. All right. And I should just start on some of these lectures as well. And also there's an online consult on Monday, right before the exam. I will need to, I guess, have a reviser revise entire course content, right? That will come. And the chances of me being able to do this becomes slimmer, but yeah, that'll be the structure of tomorrow. And I do need to revise the entire course content, okay, before I feel happy. Like it's like my final round through before I'm happy. Raja, yeah. So Shah also says, I'll suggest that first try it yourself like really hard. After that, watch the solution, and yes comes the important point. If anything comes up, like you just must solve that because you learned it now. I kind of understood that. But I wouldn't say go too hard, right? I would say don't go too hard. Because I mean go hard in the 5 minutes, I guess. Just don't go hard for like a full hour. Because it's going to be unproductive if so. It's unlikely that you'll be working hard for a full hour on one problem, you know what I mean? So here's the thing, right? Maybe I'll revise the entire course first before I look at that. Just so that I've tied it all together. So I'll do it once in the morning and once in the evening after I've done all of the other ones, okay? Like my final rundown. Before the next day, I have one more reviser of the entire course, all right? And then one more reviser in the morning of this exam. So the exam, this is the CS exam. Right. Yeah. All right, yeah, maybe, yeah, exactly then, Shah. That's it. That's exactly the way then. We're chilling. We're chilling. All right, well, let's see. What else do we need? I think we have the idea now for tomorrow. For today, we're done. For tomorrow, we have that set out. The chances of me actually finishing one of these lectures is probably not likely. This will probably have to just move to another day. Can I just do the CS exam and then do the tutorial? Maybe, you know, maybe what happens is we do something like this. if I'm really good enough, right? If I'm really good enough on my revising tomorrow, then we can do these the day after. Okay, that could be the plan. All right, well, good morning, guys. Most of you. For me, it'll be good night, and I'll catch you guys in the evening when you guys are here. So thank you for tuning in, and I'll be heading to bed, winding down now, and yeah, that's it. All right, cheers, guys. Peace.